Hey guys, this is my Dynaflux VH1000 Tig torch cooler, and I've got a little problem with it. I'm not happy with the amount of flow that I'm getting to the Tig torch. So I think what's going on here is that I've either got a problem with the bypass valve or it just needs adjusting. These are adjustable. This particular model, VH actually stands for vertical horizontal because you can run it in the vertical like this, or you can actually lay it down on its side if you need the space horizontal. Anyways, it uses a gear displacement style pump, self-priming, which is great. Has a built-in bypass circuit and check valve so that if there is a restriction in the torch lead, for instance, if this gets stepped on or kinked, or if you have this running to a water cutoff solenoid, like my big old Airco has, which I've bypassed and taken out altogether. The reason why this Airco has a valve, a water solenoid, is because back in the day, people used to actually hook these up to the faucet and run tap water through these. And, well, times have changed. Now we use recirculating systems, like this with a radiator in it for cooling. Okay, so that being said, it's a good idea that it has a bypass system. In my particular case, what's happening is a lot more water seems to be bypassing and going directly back right into the reservoir as opposed to going out through the torch and coming back. I know that because inside here I can stick an inspection mirror and I can actually see the hole in the side of the tank where this line is coming in, and this is the return line from the torch. Okay, so actually, technically, this line actually goes down to the junction block on the welder because the water is supposed to flow from the cooler right here. So this goes directly to the torch head. Goes through the torch head, cooling it. Then it returns on the power line. The power lead is actually also the return hose for the cooling. That goes to a junction block down below where it cools that junction block and the conductor, then comes up through this hose and dumps back in here. When I look inside here, I have flow, which is good, but it's kind of not so great. So these come preset at the factory at 50 psi. However, they're supposedly are adjustable up to 100 psi. So I'm going to see whether or not I just need an adjustment, or do I have a problem with the check valve, that the check valve is weaker than it should be. So I've already got all the screws out of this thing. You've got to take quite a few screws out of the back of this thing, and the 4 screws at the base here. And then this whole plastic housing will slide up off and leave the radiator, which is actually in the roof of the unit, so to speak, when it's in the vertical configuration. All right, now that I got the cover off, we could talk about how this water flows through this thing. So this is clearly marked water output. This is the main output from the pump. So the water flows out of the pump through here, out to the torch, comes back to the junction block on the welder, comes back to the cooler on this line, and dumps back into the reservoir. So there's a hole right here that when I put an inspection mirror down through the fill hole right here, I can actually see the water dumping back into the reservoir. The water enters the pump. It is actually drawn in, because this is a self-priming gear displacement pump. It actually is drawn in on this line. The water is actually pulled in on this line that goes up here to the radiator or cooler. And then you've got another line on the cooler down here that goes to this right back here in the corner that goes to a dip tube that sticks down into the reservoir. That's your pickup tube. So the way this actually works is this pump draws the fluid or the water up through the radiator into the pump, pressurizes it, pumps it out. See this second line right back here? This second line is the output from the relief circuit. So this just dumps right back into the reservoir here. So any water that is not going out the main output line right here that is bypassed by the relief valve, which is on the back side, I'll show you in a moment, dumps right out here. So what I'm seeing when I look in here is I'm seeing a ton of flow coming out of this relief line going right back in there. And I'm seeing kind of puny flow coming back from the torch. So too much is being bypassed, and I need to find out why. Alright guys, now I've turned the unit 90 degrees so we can see the back side here, and this part right here on the back is where all of the relief valve is housed. So this brass cap and then this brass nut right here are part of the relief valve assembly. So there is going to be, inside here, there's going to be a spring and some sort of a valve. Kind of in a bad spot. There isn't even a hole in this metal plate because there's a screw head underneath this cap, which is most likely for the adjustment. But you can't even adjust it without the way it's in there. So what I'm going to do is I'm going to remove that. So just a 3/4 inch wrench, and you can unscrew this cap. I had this off earlier before I realized that I wasn't going to be able to get to anything with the housing, the whole thing all closed up. And a little bit of water came out of here when I opened this. There's a little gasket here, so I think it's normal maybe for a little bit of leakage to get past the threads on this screw. So once you get this cap off, which is just with a 3/4 inch wrench, this nut right here is actually a jam nut. So if I loosen this nut, that now allows me to turn this screw. Now I was just complaining about not really having clearance to get a screwdriver in there because there's a slot on the back of it. But the reality is that once you get this jam nut released, it's actually very easy to turn this. So I could unscrew it all the way, and that would allow me to take the spring and the check valve out and examine it. But I think for starters, just for the heck of it, I'm going to try and see what happens if I adjust it. Now, the tricky part is, in order for me to run this, open up like this, I have to support the radiator. Well, if I have a blooper reel, that'd be perfect. That was just a diamond-shaped metal grate that sits on top of this. So I have to tilt this over, kind of out of the way. I really don't want to kink the hoses if I can avoid it. These hoses are pretty thick, they don't kink very easily. I think I might be able to get away with running it like that without too much trouble. I changed my mind and I just used a bungee to hang it up from an overhead pipe. Yeah, it's going to be pretty difficult for me to show you guys if the flow is changing in here. I have to use an inspection mirror to kind of sneak a peek at it. But I can stick my finger in, and I know when it's running the way it's set now, the water isn't shooting out far enough to hit my finger when I do this. So I can actually kind of see if it's changing by doing that. Actually, it does just hit my finger. I just sort of turn it up a hair more. So now I'm really satisfied with the flow. It's a lot better than it was. So I'm going to leave it at that. It's interesting that the motor speed seems to have increased as I make that adjustment. So turning it in actually puts more spring pressure on that check valve, which forces more water to go out the main output line to the torch as opposed to just going out the bypass. So I hope you find this video helpful, and if you do, please take the time to hit the like button. And if you're not already a subscriber, please consider subscribing. Take care.